Hi everyone, I'm Ramiz, and before I start my talk, I just have a small questions. How many of you here are students or in early career, just started working? Okay, and how many of you here are professionals who have worked on a lot of projects? Oh, that's amazing. Okay, so this before starting my talk, I would just like to talk a few points about myself, which is I was supposed to be a doctor, but I disappointed my parents and never really went to med school. If anyone here knows about the exam NEET, which is one of the most difficult exam in the world, I gave it. I qualified, but it was not my thing. Anyway, and I never went to college as well. Not only medical school, I never went to any college for that matter. And I haven't applied for any jobs yet. I keep saying yet on everything because Murphy's law, you never know what happens. And I am someone who loves everything. So I just call myself, like people call me myself that I am a jack of all trades, master of some, emphasis on some. So today I sort of want to talk about why is open source good for students and what problems students face and how we can sort of solve it. And then a few of who are maintainers here, what can you guys do to make projects easier for the students? So before starting, I also have we do at our organization a lot of research on students, and these are some of the stats that we have recently worked on. So can anyone guess? I think it's in the pie chart, but there's a lot of students, which is the percentage 23% students. They thought that they don't need to do anything other than their college coursework, and they thought that good GPAs that would lead to some work and job. If any of you are applying for jobs, you would probably know that that's not the case, and that's why the number is less, but it's not negligible, right? And a lot of the students thought they don't need to learn anything outside of their course to get an internship. And the number is very high, it's 45%. So the thing is, what we have found over time with all this research is that GPA is not correlated with your success to get an internship or a job. It's not at all related. And so the question comes, what you can do? And my simple answer to the question is open source, open source, open source. Just like Microsoft said, developer, developer, developer. But the problem is the question generally comes, why open source? This is a personal anecdote of mine. I learned to program in a very insufficient way, I would say, because I have a severe ADHD, so I could not go through courses. So I learned the basics, then I realized, what can I do? Then I found there are a lot of open source softwares that basically the codes are available in the internet, which was a very, weird find, I think, because I did not know anything about it, and I did not have a traditional degree or anything, so I did not know there is something called open source. So I started going through other people's code. And because I knew the basics, I tried to make sense of the code, what it meant. And surprisingly, it was very beneficial because when I was working on to do something, I knew what to do, which is not the way I think people tend to think of it, but this can be one of the great way to, I think, learn. And I say there is two experience points here. First of all, if you work in an open source project, of course you get a huge amount of experience to, that you have worked on something. But the second point is, a lot of you might be in college. While applying for your first job, you might see that other people has a huge CV with so many experiences, and you have none. So people often write very useless things. And I'll tell you, from the perspective of someone who hires, that's not really a good thing to see. So what you can do, let's say you work on an open source project, and you submit your PR and it gets merged. That's a huge achievement. And if you put your GitHub link and your work into your CV, that's actually very, very impressive. And if I am the hiring manager, which is not only me, I think there are a lot of like-minded people like me, they would obviously love it. So this gives you a, I think, it gives you a very unfair, not fair, I think fair advantage to, over, I think, other people who are applying. Now comes the part where why students are not contributing to open source software. People knows this, but why are they not doing it? And with my experience to contributing to open source and by seeing a lot of our students, I found a few things. And the first thing is what I would like to call the expert fallacy. The problem is that many students think that unless they're experts, they should not even try. And this mindset, sort of traps them in a endless cycle of studying and testing, which is very similar to what people call a tutorial hell. You learn something and you don't think you are good enough, then you just learn it again, and you never really actually go to the real world contributing. And how do you break that? So the answer is very simple. Just start doing it. This is a graph. It's not a graph. This is a made-up graph that I made. This basically shows the red line here is the threshold point. So you see, starting is the most difficult task. You start this, and then you see the difficulty levels just goes down. And after a certain amount, point of time, you just know what to do. And this is an anecdote, but so before working at CodeDay, the current non-profit organization I work for, I used to work at a company. They wanted to launch a new company in robotics because post-COVID, their business was very bad. And the founder asked me to basically develop a product for robotics. I did not know anything in robotics. I am a very software person. I did not know anything in hardware. And I did not know what to do. And the founder, one of my best friend, he just told me, you know what, just start doing it, you would figure it out. And I remember he sent me a meme that says, I don't know what to do, I'll figure it out. And I think that helps. You start doing something, over time you understand things that you would not have been understanding if you are just going through tutorials. So that's just it. And the second problem is that stupid questions. You are going to a issue that you want to solve on GitHub, but you are afraid to ask questions because you think you don't know enough about it. The point is that no one starts knowing a lot of things. It's just that. Even when I started, I sometimes go through my old chats and I cringe out because they are so dumb. But I think that's the point. Yesterday, tomorrow you should be more intelligent than today. And I think that's the whole point of it. So don't care, I guess. And now comes to the part of actual know-hows, just finding starter points. The problem is that this is a very huge hurdle, I think, because when you go to a code base which is huge, without context or guidance, knowing where to start can seem very nearly impossible, I guess. But when you are faced with an unfamiliar project, you might be hesitant to sort of dive in because you don't know what's important and where to look at. That's a very valid problem. But the thing is, so here I sort of wanted to show one of my personal anecdote again. This is the first time I think I navigated through a very large and complex code base. I was fresh out of high school. I did not know much things. And just so you know, I did not have CS in high school. So I was completely new there. And one of my friends told me that you should just go through Linux kernel. I was like, okay. And then I realized it's millions of lines of code. And this was, and also not only millions of lines of code, it's also spanning multiple subsystems, you see. And each component has their own independencies. And they have different purposes. So where do you start? And this is a matrix diagram that I took from Wikipedia. These basically, show you how to find your way in the kernel, Linux kernel. So what you do is you pick up a subsystem that interests you. This might be networking, this might be memory management, file systems, or like really anything, you can just pick them. And you just decide, you just trace, because it's very well like written, I think it's very well documented here. You trace the flow execution. For example, if you're interested in how a system call works, which is, you just trace it. So if we take system call, yeah, it's here. So what do? We go to system calls, then we go to, I think, virtual file system, then we go to logical file system, then block device and disk driver. That's there. So you have to like learn to trace this. And usually, huge projects, if they're well documented, they already have given like this kind of a matrix map, which is, I think, very, very helpful for people. Now, how do you start to contribute? That's the biggest question. My first my first contribution, it was adding a few spaces because the code looks ugly. And then I think it was documentations. That's it. You just start small. And then I think other than that, then you can just add test cases or improve error handling. That's one of the, I think, best kind of contribution that you can make as a first-time contributor. And then when you get slightly used to it, you can review open issues in the subsystem, so if you're interested in. So that's something I really recommend everyone else to do, because personally, I think this has been the way we did, and then I sort of started implementing it at our college students that we work with. Most of them actually work in solving test cases. And one of our biggest partners is OED, Open Energy Dashboard. And so far, students love it, and even the college students love it. Even the colleges love it. So this is one of the, I think, way this can be. You can just find your way in the open source. Now, the thing is, while talking about starters point, it's not only about the students who can do stuff. This is also about a lot of maintainers. So for the people who are here, experienced in open source softwares, and if you have an open source project, I think I have a few ideas on how maintainers can help here. And the first thing I think you can do is include a very detailed guideline. And like the coding conventions that you guys use, the styles you guys use, and of course a code of conduct. And adding, like you can add the contributing in the contributing MD file. Surprisingly, I saw a lot of good projects doesn't have it. And dev environment, which is one of the most important point I found out, because very recently we are working with Eclipse Foundation, and specifically in the Eclipse IDE project. And a lot of our students had huge amount of problem to just get the dev environment running. And you, as a maintainer, I think providing instructions that work across different operating systems and new contribute, basically this should be if I'm using a Mac or someone is using a Windows, sometimes people don't really give instructions for Mac OS for some reason. But I think it should, as a maintainer, you should have all the information for how to run a dev environment in different OS. And then, as a maintainer, you need to basically automate checks to help students catch errors early, to make their learning curve less steep. This is very important because a lot of the time students just get bored of it and they just never really contribute, and they start to having they think that, okay, this is not for me. And you should offer a clear overview of how the code bases fits together, so that students can see the bigger picture. Because oftentimes students are lost because they don't really know, they don't have the idea of. You need to give a sort of a bird's eye view to everything. And then comes the good first issue tag. If you are a maintainer in a huge project, you can always add the good first issues tags, where students can. This is a very easy way to find student or any who is a first-time contributor. They can just go and contribute. So speaking of which, I have made a 4-word, I think, a template for what a good first issue should look like. And the first point is self-content. So the first criterion is being self-content. And what this means is that the issue should be isolated enough to be tackled within a single file or a small part of the code base. Now, this gives the newcomers basically a focused task that doesn't really require them to navigate through the whole maze of like the separate independencies. And then we have the point of clear, which is it should provide all the necessary details, like what the problem is, what is the expected outcome, and the specific instruction or constraints. When the task is clearly articulated, students probably they spend less time gazing what needs to be done and more time coding. This clarity really help reduce their problem, like back and forth conversation that we see in GitHub happening. And that also brings one of the points I mentioned earlier. Students are like the first time contributors, they are like scared to ask questions. And the next point is decided. By this I mean that the issue should have a well-defined solution path. The maintainers should have already discussed and settled the approach so that newcomers don't have to wonder in their effort that will be overturned later. And then we have one of the very important point is recent. You don't need to keep very old issues, which I see in a lot of projects. That the project is, I think the issue is still there. It has the good first issue tag, but probably it has been already solved by someone else in a separate issue. So this is wrapping up. This is what I think this is like the framework I have made over time, and we worked with a lot of projects, and we asked them to, this is the framework that you can follow. And by, I think, working with a few projects and a lot of students, I would just like to sort of showcase a few results that we got. And so this is the one project that involved visualizing self-driving car sensors, where the students work closely with industry partners like, I think, Cesium. And then we have this project, which is another group of students contributing to exploring movies from Hubble.gl. And this was our collaboration with Uber Elevate. And this is one of the most interesting projects that we worked on. I unfortunately could not find the exact PR, so I just took a screenshot of the F prime GitHub issue, GitHub code base. The thing is, this is a funny story because one of my coworker, Tyler, he was in a conference, and he was, I think, talking about more on the line of how maintainers can, I think, make open source issues better. And one of the NASA employees, his name is Michael Starch, he was attending the talk, and he just oftentimes I think a lot of, you might have seen that maintainers don't really like students. I understand that, but I don't think it should be. And one of the coolest projects that these students worked on was working on F prime, which is a flight software. I think it's a flight software framework. It is used in space missions, and the students' contribution is actually making International Space Station operating, which is a very crucial part of it. And these examples are just not about the code. These are the proof that with the right guidance and from the maintainers, if you can solve the issues of people contributing, even newcomers can contribute to projects that have a very real impact in the world, or in your life and even our life. For example, I think whatever browser we use, regardless of the browser, we talk about, I use this browser, I use that browser. Most of the browsers, I think, are Chromium-based. And I think one of the most proud contribution I made a few years back was in a Chromium. And after making it, I think it felt good to just say to people that, you know what, I made your browser 20% faster, 20 times faster, which is, I think, something that really feels good to say, and you can always put it in your experience. And I sort of wanted to talk about a few research we worked on. This is more of the work we do as an organization, but I don't think I have much time, so if any of you want to talk about it, we can talk about it. The research we worked on with education departments and stuff. And so in the end, I would like to just say to everyone here that we can work together to help students and newcomers. So what I can do is, we made a framework, the framework I mentioned, which is mentioned in this link. You can just access it by going to this link. We have mentioned the way how you can make contributing MD files, and how can you well define your dev environment setup. or how you can just define your good first issues. And if any of you have an open source project that is looking for, I think, contributions, I would personally love to help you, making it better for other newcomers and contributors. And you can always just go to this link, and this will probably give a link to my work as well. And if anyone here are industry experts and want to work in the things we are working on, making open source better for people and working with students, feel free to go to code.to/labs mentor. And if any of you have any questions or want to talk about anything, you can always just reach out to me in my email. And I think I have 9 minutes left. If any of you have any questions, I'd love to answer.
So my question is very simple, actually. Oh, sorry, English. Can you give us an overview or a short introduction on what Code Day Labs is for everyone who's curious?
Sure. So Code Day Labs is a nonprofit organization. What we do is mostly in the US, let's say the good colleges, MIT, Stanford, these guys are the people who get good projects. They get to intern in Google, Microsoft. These companies doesn't really come to community colleges or the colleges that are not so known. But that doesn't mean that not everyone has the talent to work on these companies. So what we do is we give internship to these college students who can, and we because we have the resources to connect with, again, these same companies. We partner up with a lot of companies. For example, some of our partners are Linux Foundation, Rust Foundation, the Eclipse Foundation, NASA JPL. So these projects are very well known. So we take issues from these projects, and then we find someone in the industry who is already doing well, and these people and then these students get to work with these people as the industry expert as mentors. And the work of the mentor is to help students think like what they would think. So for example, they don't really give an answer to the questions. And we often say to play dumb because you don't really give the solution. They help you to think like that, you guys. So it's a very high level guidance. But if you have problem with debugging and stuff, we have TA supports. So the students can actually work on a good project. And then as I think a part of it, then they can just work on this project. And then if they get their work done, and then they get their PR merged. That's one of the great experience that you can see. And as an organization, we also try to push it, to make it look like a real internship, because you have to work in a team, you have to submit stand-ups, so you get a real experience to work on these projects.
Thank you so much. That was very comprehensive. Thank you.
Thank you.
Okay, we can accommodate another question. So if you have another question, don't feel free to just approach the mic. Don't be shy. Okay. All right, I think we all got it. Once again, thank you, Ramiz, for showing us how mentorship and open source can create a real impact.